Hello, my name is Madan Arumugam. I'm a program manager in Azure Compute, specifically working on open source and Linux. And I'm here to talk about architecting enterprise-grade Linux solutions in Azure Infrastructure as a Service. And this is the slide that talks about the entire portfolio of Azure services. And my talk today is going to cover several pieces here, primarily virtual machines, which touches the storage services, the networking services, but focusing on Linux and containers, of course. And we also touch on our portal and the client experiences, and I'll demonstrate a few of those today. I wanted to start with the question on why run Linux on Azure. Why run open source on Azure? There are many good reasons for it. The first and the most important reason is our customers are asking for it. They want it. In fact, 1 out of 4 VMs, 25% of all VMs running on Azure today runs on open source and Linux. So they are using a variety of open source components. They are using it for development and test purposes. They are running, mission critical line of business applications. So it's all over the spectrum. But it's a significant footprint that we want to make sure that customers are getting a first class experience, and which is why we continue to invest in features that enrich the developer and the IT admin experience using Linux on Azure. The other reason is customers are asking for an enterprise grade cloud solution for running Linux solutions, right? Similar to how they would expect for the Windows ecosystem. They're running some of their most critical applications. They are dependent on them to be up, 24/7, 365. Azure offers the best-in-class enterprise solutions, whether it's availability, reliability, and disaster recovery. And security, of course. So that's another reason why customers are asking for this. And the last one is really important, and this is unique, we believe, to Microsoft Cloud, in that Azure truly, provides hybrid cloud solutions. A lot of customers running Linux today, they have a big data center investment on premises, right? They are running, critical applications, and they want to be able to burst to cloud for a variety of use cases that we would talk about, whether it's a simple backup or a continuous, DR topology. They want to be able to use Azure as the DR target. So these are the 4 reasons that we commonly hear from our customers running Linux. And our goal is to kind of make sure that Azure is the most complete in terms of functionality, but also the most open cloud, right? And open in terms of being able to bring open source solutions on Azure with full confidence, but also partner solutions that are built on top of open source solutions. So 25%, that's something to keep in mind. And this 25% number, 25% of VMs, it used to be 22% and 20%, just over a year ago. So there is a significant growth of Linux usage on Azure. Now let's talk about the enterprise application patterns specific to Linux running on Azure, right? When we look at the spectrum of that usage, we see basically a transformation that's going on. Customers are basically, taking server applications that are built for on-premises. And this is a classic stack, right? You have the infrastructure as a service, you have the compute network and storage resources, you have the operating system of choice, the different flavors of Linux that you would choose from, and then you build clustering solutions on top of it, because you're running not on one server, but multiple servers, tens of servers, right? You're running a database application, you're running a web application, whatever your frameworks of choice be, right? A web app, a social app, a mobile app, you're essentially running on tens of servers. And your application is built on top of the stack, right? Everything has to work in unison for your application to be performing well. Now, when customers are going through this transition to the service as well, what's happening, the scale is just exploding. It's no longer tens of servers, it's services, and it's hundreds, if not thousands of services. So your architecture needs to evolve to be able to support, that kind of distributed, connectivity and communication. So on the Azure side, we offer, from an infrastructure point of view, a hybrid, consistent infrastructure with Azure Stack and Azure, where the APIs that we provide are exactly the same. And then you have the virtual machine and the container infrastructure, where you would actually run your workload. And just like the on-premises stack, we have a cloud scale clustering, brokering, and queuing solution. And you can see, up above, from an application development point of view, you have the same needs. You have to build a mobile app. It's just that it's built for the cloud scale. And you still have to support the frameworks that you need, you still want to use the languages that you want to use. And then typically in this kind of scale, you wrap all this around with the DevOps tooling, right? You have your configuration management solution, you have a continuous integration, continuous testing solution. So what is going through as we see this transformation is that customers are in different points of this journey. And these 4 phases or 4 patterns of usage, application patterns of usage, is what we most commonly see on Azure, especially as it pertains to Linux. The first step that customers typically do when they want to consider cloud is to do development and test in cloud. For obvious reasons, economies of scale, you don't have to maintain the capital infrastructure, you use it and you throw it, right? You can tear it down easily. So you really kind of go as demand, right? So just in time demand cost economics play a huge part in making this effective. And then when you continue to go along that path, the next point in this journey is really to kind of lift and shift applications that you have built on premises that you were saying, like, look, I can afford to run this on the cloud because the performance requirements are met, the functional requirements are met, where you don't want to redo the application, but you want to be able to, as much as possible, just forklift it and run it on cloud. So that's the next pattern. And then if you want to go on your journey beyond that, this is where you're creating new applications that are straddling between 2 environments. Your on-premises environment, where you have your existing tools, and then you're using a little bit of the cloud economics, either for backup, either for DR, or maybe an application that's going back and forth, right? Replication, cross-replication between them. So we have several application use cases there. And then the last, but not the least, which is what the North Star for many cloud scale applications is to be able to run at hyperscale. And hyperscale is the notion where applications get location independence. It doesn't matter where you're running. You're able to kind of run across multiple regions, multiple clouds, multiple data centers, including parts of it running on your laptop, right? And the containers ecosystem is essentially innovating in this particular application pattern. So now with this framing in mind, we'll walk through what Linux capabilities you have in Azure for each of these application patterns. And if you plot this across the application portfolio that we saw earlier, we basically, the relevant services that matter here from a Linux point of view are the end-to-end IaaS to PaaS spectrum, right? So IaaS as in, you get ultimate control, you bring your own, software, you manage it, you patch it, to the other end of the spectrum where you get, really good cost and agility, cost savings and agility, trading off for some, relinquishing some control. So if you plot the spectrum, so you have the virtual machines where you're bringing your own Linux VM, bringing your own distro, installing the software, managing it, the entire application lifecycle management. If you say, like, look, I'm doing this already on premises, I'm glad that I don't have to worry about hardware management. That's great in IaaS, but I want to automate it. I want to automate everything. So Azure has this technology called VM extensions and containers, both of which supports the Linux and the Linux ecosystem, which I'll show some demos. This is really going after the problem of being able to automate everything, being able to automatically, without manual intervention, do the entire application lifecycle management. If you want to go beyond the next part of the journey, which is, I really want to have a declarative way to kind of scale out and scale in, which is really a cloud design point. If you want to take advantage of the pay-as-you-go economics, you want an infrastructure that can elastically scale out and scale in, right? Just based on demand, programmatically. And that's where, we have this upcoming service called VM Scale Sets, which I'll show a demo as well. And we'll talk about how that supports Linux. And last but not the least, your application platform as a service. We support, both, third-party platform as a service like Cloud Foundry. We are building a container service that would allow you a container-based platform as a service solution. We have also announced that Service Fabric, which is the first-party platform as a service from Microsoft, would be supporting Linux in near future. So that's the entire spectrum. The key point here is, you just bring your Linux application, and you're able to kind of take advantage along the spectrum, right, without compromising on any of your application needs. All right, so let's jump into demos. The first thing that I wanted to talk about was the dev test application pattern. And here, we have several things that are relevant. The first thing is the set of tools that you need to install in your client, your laptop, your Mac, or your Windows PC, or your Linux desktop, so you can actually interact with Azure resources. And it's really important because for a Linux user, this is the first point of interaction with Azure resources. So I'll quickly demo. I'll show you what's a good best practice of doing that. So in my screen, you'll see I've opened basically Docker Hub. And Docker Hub, as you all probably know, is a collection of container images. And Microsoft actually publishes a few container images. And as you can see, Azure CLI, which is the Azure command line interface for interacting with Azure resources, is a container image itself. And as you can, if you click here, you'll see it's a pretty simple command. So if you're running on a Mac like me, what I would typically do is just start up Ubuntu Docker. Ubuntu Docker is just a tool that allows you to create a Docker VM running on your Mac. You see. Got it. Let me make the resolution a little bigger so you can see. Then all I have to do is do Docker run. I want to run it interactively. And then I just install the container that has everything configured for me to get going, right? So the Azure CLI with all the dependencies. Azure command line interface is built on top of Node. So if you were to do it on your own client machine, you have to kind of install all the dependencies. This is a nice, easy way for a developer to just get going as fast as possible. And you can see that, I basically already inside. So what I've done is, let me go to my other terminal where I have everything pre-configured. The reason this is powerful and this is a good best practice is, in my case, in my dev machine, I already have a container that I'm going to jump into. And you'll see I've already, if I looked at my container, I've already logged in. I've already set my subscription that I want to use, which is the command for Azure account set. And once I commit this image either locally or into Docker Hub, I basically don't have to kind of go through the steps over and over again. You would have to make sure that, if you're committing it to a private, a public repository, your container image, you don't want it to be already, having all the credential information. So just be careful there. But it's a very, very easy way for us to create a developer environment that's portable. Now, if I have this container image, I can go to any machine, a Windows or a Mac, or even if I am, going to a different environment, maybe a different office site, and I can just basically, prop up and hydrate my developer environment just like how I want it. So let's try and do a login, just so as a way of demonstrating it. So in this case, I am using my Microsoft ID. I'm going to type in my password. And what you'll see is I'm using an organizational account, right? So, I'm using the Microsoft organizational account. And this is enabled for two-factor authentication. This is a very recent feature that we enabled and very, very relevant for enterprise application developers using Linux on Azure, because obviously you want to make sure that you're secure. So a multi-factor authentication solution is a must in these cases. So what you would see is I've logged in, but it wants a second level authentication. And it's asking me to go to this website and enter this code, which is what I'm going to do. I'm going to go to my... go here. I type in the code. I say continue. If I go back to my terminal, you'll see, in a few seconds, I'll be logged in because I've essentially done a two-factor authentication at this point. And that's it. You're basically now securely accessing, Azure resources. Let's see how this is going. Oh, I was a step that I missed in, so I actually have to log in, the second factor authentication. I do have an MSDN account, as you can see, so it's basically saying I have to choose which account I want to use. I've linked them together so that I can cross-share the resources. There it goes. The two-factor authentication is complete, and if I now browse for my resources, I have multiple subscriptions in my account. So if I say Azure account list, you will see I have a bunch of subscriptions. And if I say Azure VM list, it's going to basically execute a command that would say, all the VMs that I haven't. But we won't wait here. So if you go back to the slide, so the first step is to kind of make sure that you have a very easy experience to onboard into the Azure platforms. You have all the tools, the developer environment necessary for your Linux developer box to interact with Azure. So that's what we saw. Okay, you got that. Now you basically are ready to kind of go create a bunch of machines, right? The virtual machines. There are several options for how you get started. The first option that I'm going to talk about is you can actually go browse our marketplace. And if I make this a bit bigger, so right here, I'm logged into my portal. It's just portal.azure.com. I go to new, and I want to go look at the marketplace, see what we have. There's a whole lot of Linux-based solutions that are available, right? Hundreds of, and you can see, the first one that shows up is the DataStax Enterprise Cluster. It's a Cassandra Enterprise solution from DataStax. And I can actually search for anything that I want. Maybe I search for, I want a LAMP stack and see what we got, right? So, I can basically search through hundreds of thousands of solutions to kind of get what I want. And then I just have to go to create. It'll ask a bunch of parameters, and that's it. I can get going. So that's one path, right? If you go back to the marketplace here, you would notice that there are different types of content. You will see, we have basically organized by different facts. So there is a set of Azure certified content. And what that means is this is content that is certified for Azure by the third party or a first party, like Microsoft solutions. And there is basically support behind it. You will see a bunch of these solutions, SAP, Oracle, IBM, and so on and so forth. And if you look at the Linux-based solutions, I want to explore what we have. You will see there is two types of content, the first party and the third party Azure certified content. But you'll also notice that we have a bunch of content that are coming from the community, the open source community. And that's what I wanted to talk about. So Azure certified marketplace is one content. The community-focused content is hosted in our website called VM Depot. And VM Depot is basically as, a community-based, image hosting solution from Microsoft. Originally Microsoft OpenTech, which designed the solution. And what you will see is a variety of these. Anyone in the community should be able to go, host an image. If something works for them, you can see there is a mean stack. And what will happen is you basically putting this image, but it doesn't come with any strings attached, right? So it's basically open, free. You can, take an existing image, make changes for it. And if you feel like it's something that you can share to the community, you could do that as well. And we have a nice user interface here as well. If you see, I can directly create through a Linux CLI, I can create the necessary commands that I want and just copy and paste to the terminal. So for example, I want to deploy this image that has the mean stack configured. I want to pick, let me make the screen clear. And here you go. The exact command that you need to type in your terminal that I just showed right here, I can just cut and paste this, make whatever changes that I need, and off I'm going, right? Again, the theme here is to get started as fast as possible. And then if you go back to the marketplace, we have another category of, solutions for Linux based on containers. And containers, if you think about, we go to the marketplace here, the container apps, and you will see all we are doing here is, we have a bunch of official content that's coming from Docker Hub, these popular container images that customers are using, that we've integrated in a nice portal experience in Azure, right? So, this is a Redis image that's coming from the Docker Hub, a MySQL image. So any of these images, you can just click. You will have a very similar experience to creating a VM. So, you go through a set of steps. You can do basic settings, and you'll see, it'll ask for some names, container-specific inputs, and then off you go. You have a Docker machine, a Docker host running on a virtual machine with the container running for you. So behind the scenes, we are actually using Docker Compose to bootstrap this, this particular container running on the VM. The last thing I wanted to kind of quickly show you is a set of open source templates that we have been innovating on. So if you look here, it's basically in GitHub. Anybody can contribute to it. Microsoft actively contributes to this. We are creating a whole bunch of content for Windows and Linux, but there's a lot of Linux content here. And I'll pick an example. Let's say Apache 2 on Ubuntu VM. What you would see is a bunch of files, right? Like you see a bunch of JSON files. Azure supports what we call as a template-based deployment. So you can declaratively express what you want to deploy into Azure, a single virtual machine or a bunch of virtual machines. In this case, it's a single virtual machine. And it's a JSON file that tells the Azure control plane what you want to deploy, right? So you basically, we have created a JSON file, but an easier way to kind of show through the experience would be through Portal. So if I go to deploy, all I have to do is just click this button, deploy to Azure. It locks you into the portal, and it sucks up this template that I was just showing you in GitHub. And in a few seconds, you will see that the template that you just saw is already here, right? It's basically copied the template, and it renders a nice user interface where you can just provide the key information that you need to bootstrap this particular application topology. So I need to provide a storage account name. So you're telling Azure where you want to store your data, which location, you pick from the set of locations that the template allows you to do. A username, password, a DNS name, the version of the base operating system, in this case Ubuntu, and off you go. So really very simple. In a few minutes, you'll be able to create entire application topology. And this is important. The set of templates that we are creating are becoming your reference architectures, right? We are constantly listening to customers. We are looking at all the best practices that you need to optimize your Linux or open source application on Azure, and we are essentially codifying it. This is infrastructure as a code. The easy way to get it is obviously go to GitHub, but you can also go to azure.com, and we have up front here. If I go to community here on the top, and I look at templates, we have a nice user interface that allows you to search for whatever you want, right? So say, for example, if I want a Docker related template, I see a few here, create a Marathon, Chronos, Swarm enabled Mesos cluster. So this is a Docker enabled infrastructure, if you will. All right, so the last thing I want to show in the templates here is simple, let's say a Django app, right? This is a Python framework. Say I want to deploy a Django app. This happens to be something that I wrote. And what you would do, I want to actually show you the template because I wanted to show you something that is very, very powerful for Linux users. What we have here is basically using the technology called VM extensions that is embedded and codified it as part of this template. And what you see here is, all I'm doing is, creating a virtual machine. There's a bunch of code there that's essentially creating a virtual machine, creating a network card, getting all the other storage and networking resources created. But at the end, what I'm doing is after the VM is booted up, this Linux VM, I want it to do something. I want it to run a script. And in this case, I have a script called install Django. It's basically all it is doing is just installing the packages from the package manager for Ubuntu and installing Django, configuring the ports, and standing up a web server. So I'm telling this particular technology VM extensions like, hey, I want to actually run the script. Here is the script. Go execute it right after the VM is booted. So very, very simple, very, very powerful. You don't have to worry about it if it's all codified in the template. But if you do want that power, you can actually go do pretty much anything you want inside the VM that is executable by a bash script. So, or a Python script or any language of your choice. All right, so we talked about the dev test. A lot of options, very easy to get started for Linux users, starting from setting up your environment all the way to kind of getting going, so your application topology is set, so you can get going in terms of codifying your application. So just as a summary, so you can start from a marketplace image. You can start from Azure certified images in marketplace. You can start from a community image in a VM depot. You could bring your own. You could bring your own custom VHD with whatever flavor of operating system you want. Applications installed in it. That's a viable route. You could use extensions. You can install a vanilla VM either from marketplace, a community, or bring your own, and then customize it after. Install whatever applications, configure ports, so on and so forth. And then last, this whole container phenomenon that's happening. We have that that way of installing and managing applications as well. So the key point is easy. We support a spectrum of options. Whatever works best for you, you should be able to do it in Azure. All right, so let's talk about the next use case pattern, which is lifting and shifting. The key thing with lifting and shifting usage pattern is I want to make sure that I am not, perturbing the compatibility of the application. The application is running fine on premises, right? I want to be able to just forklift it and put it on Azure, which means I don't want to go and code again. I want to do as minimal things as possible, right? In fact, that is the advantage of infrastructure as a service. So a lot of the templates are essentially creating new content. if you're doing your lifting and shifting, Azure supports a variety of services to help you migrate from whatever your source is, whether maybe you're running on a Hyper-V on-premises or a VMware managed infrastructure on-premises, or even other clouds, right? We have a solution with Azure Site Recovery. Azure Site Recovery is our umbrella service that supports migration and cross-replication between different host environments and target environments. And it supports multiple clouds, so you can actually move a workload that maybe is running on Amazon or Google and forklift it to Azure, or maybe you're starting from on-premises, you could do that as well. And we support Linux operating systems or Linux applications running on it. What I wanted to do is once you get past that stage, right? So you're running your application on Azure, you want to manage the application. You're not having control on the host, or the physical infrastructure anymore, but you still need to know, is your application performing properly? So monitoring and logging of the health of the system is something that you want to get, transparent information. So we have, if I go to the portal, what I'll do is I'll take a look at the VMs that I'm running. So I'm looking at all the resources that I'm running. I'm going to pick a resource group called Madan Docker. So it happens to be a virtual machine with that is configured as a Docker host. So I'm going to click at the virtual machine. And I'm seeing a bunch of properties. You'll see a bunch of information about the virtual machine that's going to pop up. And what you'll see shortly in the monitoring tab is there is a bunch of information that's showing up. It's showing the CPU information. All this information is being collected because I am able to kind of, go to this diagnostics tabs here and configure what information that I want it to be collected. In case of Linux, we essentially collect syslogs. So I can essentially say on, and I can go and basically configure what specific information that I want. In this case, I don't want to do it. I already have it. So if I go back to my portal, let me show you an example of a VM where I actually already enabled it for collecting diagnostic information. So if I go down a little bit, I got to click on the VM first. That would help. So once I opened up the VM, it's going to start showing you a set of diagnostic information. And if I go down, I'm going to show you an interesting tile here called boot diagnostics. What it is say you're basically, you brought your own Linux virtual machine, or you started from a community or a marketplace, a certified Linux virtual machine, and you find out that your machine is no longer booting, right? We have a nice way to actually go and look at the serial console logs that we are collecting in the underlying infrastructure, so you can see what's going on. So in this case, the VM is working fine, but you'll basically have the entire output saved for you. You can take a screenshot of what's happening right now in the virtual machine from the host infrastructure point of view. Often for Linux applications, this is a critical need, so you can, troubleshoot, and self-diagnose, without having to call support. So this is an important information that you need for ongoing management, application lifecycle management of a Linux application. The other thing that you would want to do is, in addition to just looking at the boot diagnostics, say I do want to, configure and collect, syslog, right? Like in a performance metrics running inside the Linux virtual machine. So I click on diagnostics, and in this case I have enabled. So there is a basic set of metrics that I'm collecting for Linux. We have a new service called Operation Management Suite that we announced a few months ago, which actually supports Linux as well. And what you would have to do is once you enable this, there is an agent, an extension we talked about, a diagnostic extension that's running inside the VM, collecting a set of basic metrics and pumping it to a storage account. And in this case, it's basically the storage account. So what I would then do is I would go to the Operation Insight service, which is a service that I have here in the classic portal. Let me make my screen a little bit bigger. And what I'm doing here is I'm going to the operational insights, and I've basically created an application that I would be able to configure the storage account that I want. So you can hook up the storage account that is collecting the diagnostic information that you can easily visualize and act upon, right? So I can add a storage account. I can pick from the set of storage accounts that I have. And then what would happen is, I would pick the type of logs that I want. In this case, it's a Linux virtual machine. So I would say, get me all the Linux information. And when I do this, I would basically get to a point where I can visualize all this information in this nice dashboard. In this case, I haven't set this up, but essentially the steps are as follows, right? Once you upload the storage account, after a few minutes, you'll see, the data just flowing in. So, you have a really nice dashboard that shows the application health. You would be able to do log searches. All the logs that are collected from your virtual machine or a set of virtual machines can be then quickly searched. So that's basically the focus on lift and shift. What I wanted to do next is talk about hybrid. I don't want to demonstrate hybrid. There are other sessions that are talking about in detail, but the two notable mentions for the hybrid services that support Linux are, the Azure VM backup service. This is basically a managed backup service that would take backups of your virtual machines, a Linux virtual machine for sure, and or Windows virtual machine if you're using both. And then the backup Azure Site Recovery, which is essentially allowing your machines to be backed up if your machine is running on premises, your Linux application, and you want that to be backed up in Azure and then restored in Azure. Those type of orchestration is done through Azure Site Recovery. All right, let's jump to the next dimension, the application pattern called hyperscale. So as a reminder, so we talked about hyperscale as the cloud native set of applications that are built for really large scale, like microservices, hundreds, if not thousands of services interacting with each other, right? Very dynamically, very distributed fashion. So the VM scale sets is the offering that we are still working on. It's not yet available for preview, but we announced it in build, and I wanted to kind of show you a quick demonstration of how that would help you achieve auto scale, because auto scale is the key design point for cloud scale applications or microservices architecture. So what I have here, I'll go back to my portal, my screen. What I've done here is I've essentially created a virtual machine scale set. And the way I did that, and I'll quickly demonstrate that. And this is a public template. When we make the VM scale sets available publicly for preview, what you would see is, I can basically look at a template similar to the template that I showed before. And I want to be able to deploy a Mesos cluster on a set of virtual machines. The key design property of virtual machine scale sets is, if you think about dealing with applications that are running on tens of servers, right? Each virtual machine has a unique name, a unique IP. It's basically managed on an individual basis. Now with microservices architecture, because the scale is so large, you can't afford to manage virtual machines with unique names, one at a time, right? So this is the notion of pets versus cattle, where you're dealing with so many virtual machines that, they all have a pattern. They all look identical, right? So you want to manage them as a logical entity of tens, if not hundreds or thousands of virtual machines, right? So that's the infrastructure service that we are building called virtual machine scale, so that allows you to do. And an example application, a Linux application, would be a Mesos cluster. It's a Mesos infrastructure that allows you to create a container service on top of it. So all I would do is just say deploy, and I'll quickly show you what this looks like in terms of the actual template. So it's logging to the portal. It's going through the steps that I showed you before, except this is a different template. And if you go look here in the template, let me go through. I'm creating network resources, the necessary public IPs that I need. But the key step is here. I'm creating a single resource called virtual machine scale sets. I'm picking the region, and I'm telling it I want n number of these. In this case, it's a slave. Mesos, as you know, is a master and a slave pattern. I'm creating n number of slaves. So if I go back to, and I can just say, I want, maybe 25 virtual machine slaves for a Mesos master. I copy my SSH key, I pick the location, and off I go. You're basically, kickstarted creation of, tens, hundreds of virtual machines with a single call or a single experience. You can, of course, do this in CLI as well. But if you go back, I've already created one for demonstration purposes. So if I go back to my resource, so I've created a Mesos cluster running on a virtual machine scale set. And you'll see a master. And if I go to master, I want to log into the master, so I can stand up the Mesos dashboard and see, if it's recognizing all the slaves, right? So, it's basically opening up the VM. It will find out what the IP address is. In fact, I actually already know what the IP address is. So I'm going to just jump. So this is the IP address. And as you can see, I've actually opening up the Mesos, the master. And if I log in here, I will refresh it. I created yesterday night. I've basically got 12 slaves, right? And if I look at the slaves, it actually has a pattern of naming these slave machines, and everything is looking good. Now, right at this point, all I have to do is just deploy my application and get go, right? So it's pretty easy. Now, say I want to scale out. I want to increase the scale or maybe scale in based on demand, right? There's a simple template here that allows you to do this. And I'll quickly show you how this looks like. So again, it's the same. It's a snapshot of a template that all it does is changes the instance count, right? I already have the VM scale sets, right? So I'm going to say, look, the name of the scale set that I want to change the number of instances is slave set, and I want to say I want to make it, I don't know, from 12 instances to 6 instances. It's deployed in East Asia. Say okay. I want to select an existing resource group because I want to operate on an existing one. So let me go and choose the one that I want. This is the Mesos VMSS RG. It's in East Asia. I want to review. Click OK. And this gets going. Say bye. I want to pin it in the dashboard. I say create. And what you're seeing now is my deployment is started. And in a few minutes, I'll come back to show this. My Mesos cluster would have shrunk to 6, right? Basically half. So think of what you can do with this kind of capability, right? So you can actually have a container-based application running on a Mesos cluster in this case that can dynamically scale in and scale out without you having to ever log into each of these VMs and manage the infrastructure, right? So it's pretty powerful. And there's a variety of applications that can use this functionality. You can think about, I don't know, a data stacks infrastructure, any application or there is any application stack in Linux and open source that are building large hyperscale services, right? A data tier or a mid tier can use this, VM scale set service. While that is going on, I'll come back to show that the Mesos cluster has shrunk. What I wanted to show next is, our support for third-party platforms as a service, right? Specifically, a specific example that I would demonstrate is Cloud Foundry on Azure. So with Cloud Foundry on Azure, Cloud Foundry is a very popular third-party open source, framework. It's quite popular in private cloud. The customers are starting to use that to deploy on public clouds as well. So it's a nice story for you to use an application that can be portable to multiple cloud by using this framework, a PaaS framework. So what I'm going to show you here is an example of the work that we are doing here. So this is all done in the open source. We are working with the open source community, Cloud Foundry community. And we have a set of steps documented on how you can kind of bootstrap your environment to get going as fast as possible. As you would see, the common theme of integration that we have with open source application is to do what is absolutely necessary to bootstrap the open source ecosystem on Azure and then get out of the way, right? So really, we are interested in making sure that customers find it easy to onboard to the Azure platform and they continue to use the tools that the community provides, right? If it's a Docker ecosystem, the Docker CLI should just work. If it's Cloud Foundry ecosystem, the Cloud Foundry, tooling should just work. In this case, the work that we've done is basically implement a CPI or a cloud provider interface for the BOSH, and it goes through a set of steps. What I've done for demonstration purposes is I've already created the environment, and again, creating the environment, after you configure the CLI is really easy. What I'm going to show you is a quick sneak peek at a template that we've created. Again, templates make it very, very easy for you to create complex architectures that essentially requires multiple virtual machines to be wired up, network resources and storage resources. All of that can be codified, infrastructure as a code. So we have an Azure template that allows you, I think I clicked on the wrong link. We have an app, Azure template here. You'll see, again, it's basically a set of JSON code that is telling, all the resources that you need, how they need to be wired up, and so on and so forth. So just like how I demonstrated, you can just do a single click deploy to Azure right here, and you would basically end up with an infrastructure that is good to go. And that's exactly what I've done here. So if I go to, it basically created a set of virtual machines. In fact, let me quickly show you what that looks like. If I go to the resource group, Let me look at the Cloud Foundry Preview 2 that I created. And you can see here that I've created a set of resources just by deploying the template. I have the jump box, which is the Madan CF Preview 2 machine. I have a bunch of network resources, storage resources, and so on and so forth. So if you log into this VM, this is the VM where you would actually deploy Cloud Foundry, which is what I've done here. Madan CF Preview. You will see the bunch of files. Stay familiar. If you're a Cloud Foundry user, you would just go and edit this file for the information that you need specific to Azure right here. You would put the tenant ID, the client ID, the client secret, and you would just run this command, deploy posh, and then it would just get going. So pretty simple. And again, the theme is to get you started as fast as possible. So a variety of PaaS, open source PaaS frameworks are easy for us to kind of get going on Azure. Let me quickly check if the Mesos cluster, and as you can see, if you can see the screen here, if I go back to the Mesos cluster, I have now autoscale. The autoscale is completed. Remember it was 12, now it's 6. So, coming back to that first demo that I showed on hyperscale. All right, so the last part of the session is focused on the top best practices. In fact, I have 10 best practices. There's basically 3 themes here when you think about best practices. There's a set of activities that we see customers doing to get started fast. And the thing that I demonstrated earlier in the session, which is use the Azure CLI Docker Hub image. Containers are really powerful in terms of improving developer productivity, and we want to make sure you getting started to develop on Azure is a easy and a smooth experience. So as I demonstrated, you can use the Azure CLI image. We keep it up to date. Every time we release a new version of the Azure CLI, you would see it on the same day in Docker Hub. The second best practice there is, always check for the Azure integration components to be the latest when you're using the virtual machine. Regardless of where you started, in creating a virtual machine, whether it's from a template, whether it's from your own, on-premises environment, you brought your own VHT, or you started from an Azure certified virtual machine, or a community image, there are 2 components that you want to make sure that they are up to date, right? One is called Linux Integration Services, and this is a core component that is essentially managing the interaction between the virtual machine, the Linux virtual machine, and the Azure, compute infrastructure. It's important that you have the latest and greatest. All popular Linux distributions, we already work with the distribution partners to get embedded as part of the Linux, kernel upstream. But there is obviously, some time lag between, when we make the changes. So we work with all the distribution partners to make, updates to the images that they publish in Azure as soon as, a new version of the Linux Integration Services, LIS, becomes available. So, if you're running into any issues, the first thing you want to check is what version of LIS. The second component that is also important is called the Linux agent, or the Azure Linux agent. It's an open source agent that runs within the virtual machine that, again, communicates with the Fabric infrastructure and helps you with implementing these extensions that we talked about, right? The Docker extension or the Chef extension, all the Linux extensions use this agent. Again, you want to make sure that you have the latest and greatest. Often when we see customers run into issues, it's because they are using an older version of the agent or the Linux Integration Services. Talking about extensions, that's the second category of best practices I want to talk about. Extensions, as I demonstrated to you, is a very powerful mechanism for you to customize your virtual machine. You can download, and configure your open source software, not just in one machine, but a fleet of virtual machines very, very easily. You don't have to open up ports. You can basically, use the same security model, the authentication authorization model for Azure that you use to interact with these sources right from your Azure CLI to, customize your virtual machine. And we have a variety of extensions. The couple that I wanted to call out are the custom script extension. This is the extension that you would use to run an arbitrary script at arbitrary point in the lifetime of the virtual machine. The other extension that I would call out as a best practice is often we see customers running into cases where you forgot your password or your SSH key and you can't log into your virtual machine, or maybe your virtual machine just doesn't boot and you need to reset the password. We have an extension that allows you to do that without having to worry about how to brick that virtual machine to get into and get access. Right? It's called a VM access extension. You'll find the documentation online. And then the last best tip or best practice here is our extension ecosystem has a timeout where if you're running a custom script extension, it times out if the script doesn't finish after 90 minutes. So if you have a long running task or an install that takes more than an hour and a half, split it into multiple calls or multiple scripts so you can actually stage that activity. The last section that I wanted to talk about in terms of best practices is Azure Resource Manager, which is the template engine that I demonstrated earlier in the session. The first thing that you want to make sure is it makes templates. Templates are very easy for you to deploy a complex application infrastructure. But the first thing you want to check is, do you have the right limits for your subscription? We have a really nice documentation that I'm going to show you here. That's if you search in Bing or Google, you will find it. And it's an important detail that you should pay attention. There are different types of Azure accounts. You want to make sure that the different limits for the properties, right? The number of local networks you can have in the subscription, number of cores you can have in a subscription. So when you deploy a template, you don't want to find out after, a few minutes that it failed because you didn't have the right capacity, the right number of cores or the right number of, network addresses and so on and so forth. So very important, we see a lot of support cases because of that. Azure templates, I talked about in detail. I demonstrated a few. That's our effort to codify, the best practices for running Linux on Azure platform. We have, tens, if not hundreds of templates that community is developing. If you see an application that is not there, help us build that template. We want to make sure that if you want to start on Azure with a new Linux project, you start there. So all the best practices are already codified. You don't have to go through and reinvent again. All open source components work well on Azure, like all the way from OpenVPN type solution to a Docker solution to a Chef or a Salt like configuration management solution. We want to basically support all the open source application infrastructure. So if there is a gap there, if something doesn't work, let us know. We are listening to you. We want to improve that. And then the last tip that I would share in this particular slide is, often, when you're storing your customer secrets, like you're creating a virtual machine, you have a SSH key or a password, we have a managed service called Azure Key Vault, which is essentially a key management service without you having to worry about hardware, like a certified hardware that would actually manage your keys. It's a very nice option for you to kind of put all your SSH keys or passwords in one place that is managed in a global infrastructure and then refer to it for any of the Azure services that need it. As key takeaways of the session, as I wrap here, there is basically three key takeaways. One, first of all, it's very easy, as I demonstrated, for you to get started on Azure. If you've never tried Linux on Azure, try it out today. I would encourage you to try out. You can get a free Azure subscription with, $200. It can give you an opportunity to try out what we have. Bring the open source tools that you love and use today. They all work in Azure. If it doesn't work, we would love to hear about it and address, any gaps if there is any. And then the last one, from Azure point of view, as you can see in the slide, we understand that the world is heterogeneous, right? Customers use different application frameworks, PHP, Go, Python, Ruby, Java. So we wanted to make sure that we support the entire gamut of these ecosystems, right? We want to be the most open platform, both from the partner solutions that are available, the open source ecosystem, as well as the community solution. So if there is a gap there, we would love to hear about it. So give us a try, and we'd love to hear from you. Thank you.